Hey, today, lesson 98. This is a very full lesson, so I hope you are hydrated and fed and you're tucked in, ready to learn. I also want to make sure that this lesson that you do take notes from it. I am also presenting the distance formula, which is not given in your book, but I think it's much more helpful for finding the distance between 2 points. The book shows you the examples where they plot 2 points, okay, so 4, 2, and -3, -2, and I've plotted them for you, and they show you the method of using the Pythagorean theorem to find the distance between these points. So what they do, they drop down a perpendicular here, okay, and they write the perpendicular here, okay, and so they create a right triangle. So the distance then from here to the drop down would be 4 units, okay, if you count 1, 2, 3, 4. And then from here to here is 7 units. So you see we've created a right triangle, so we could use the Pythagorean theorem. We could say that 4 squared plus 7 squared is the hypotenuse squared, right? This is what we're looking for. So we have 16 plus 49 equals c squared, okay? So c squared then is 65, okay? And so we would take the square root of both sides, and so c is radical 65. There's no way to simplify that. If I wanted a decimal approximation, I could plug that into my calculator and get that, okay? So that is how the book is showing you how to do that, and that's fine, but there is a formula, and why not learn it? It is important, I think, that algebra kids know how to do that. So remember, we got this to be radical 65, so let's see if we plug it into the distance formula, if we'll get the same thing, and of course you know we will. So first of all, very important is that you write down the distance formula. So distance equals the square root of the change in the y coordinates, which we'll call y2 take away y1 squared, plus the change in the x coordinates, quantity squared. So I hope you can see that, okay? So what you're going to do is name your points. It doesn't matter which one you name. You could say this one's 0.1, this one's 0.1, doesn't matter. So let's go ahead and label this one 0.2. So this is going to be x sub 2, y sub 2, and this is x sub 1, y sub 1. Okay, do you see what I'm saying? X sub 1 is -3, y sub 1 is -2, x sub 2 is 4, y sub 2 is 2. All right, so we're going to plug these numbers into the theorem. Okay, now you don't have to memorize this yet. Probably will for Algebra 2 and geometry, but yeah, memorize it, great, but I'll give it to you for quite a while. All right, so let's plug it in. So we want y sub 2 right here, 2. Now the formula says to take away, and we're taking away a -2. All right, so I'm going to be very careful with my signs and my parentheses. Now x sub 2, which is 4, take away, and the x sub 1 is a -3. All right, so you guys see what I've done here? Plugged the numbers into the formula. All right, so now inside this parenthesis, I'm going to be adding the opposite. So this is going to be 4 getting squared. I'm going to add the opposite. This will be 7. All right, so we have the square root of 16. Because remember, 4 is getting squared. Plus 7 squared is 49. Oh my goodness, that's just what we got ahead earlier. So as you see, the distance formula is really easy to plug the numbers in. Instead of having to plot on a graph, drop down perpendiculars, count your spaces, find out what your sides, your legs are, and use the Pythagorean theorem, just apply the distance formula and it will be quite simple. Okay, so let us do another example. So it says on 98.1, or actually we just did that one, let's do 98.2. So it gives us 2 points, 3 and -4, and then negative 5 and 2. So let's use the distance formula and find the distance between these two guys. You can look at the example in the book. They draw the picture and they drop down the perpendiculars, form a right triangle. I'm going to use the formula. So distance I know is, let me label my points first. I'll do that. So I want the change in the y. So y2 minus y1, quantity squared, plus x sub 2, take away x sub 1, quantity squared. Extend your radical over the whole thing. Okay, so in this parenthesis, 2 take away a negative 4 means I'm going to add the opposite. So in the parenthesis is a 6. 6 is getting squared. So that's 36. Now here I have negative 5. I'm going to add the opposite. So this is a negative 8, right? And that's getting squared. So negative 8 getting squared is 64. Okay? So the square root of 36 plus 64 is 100. Oh, how wonderful. And I know that it's a perfect square. So the distance between those 2 points is 10. All right, the other formula that you're going to use is the slope formula. And that formula, I'll give you that one because sometimes they want you to find the slope of the 2 points. All right, and you could draw them and then you could say from one point to the other, moving left to right, how far do you rise? How far do you run? So that would be a positive slope. Or going left to right, if you sink and run, it will be a negative slope. But there is a formula, and why not use it? It's a little bit easier. So the slope formula is m equals the change in y, change of course being the difference, and the change in x. So take away y2, take away y1, over x2, take away x1. So again, we've labeled our points, so let's go ahead and find the slope of this problem. So y sub 2, 2, take away a negative 4, over negative 5, take away 3. All right, so this is 6, this is negative 8, you want to reduce, and so the slope, hope you can see that. Okay, the slope of these 2 points is negative 3/4. All right, so you've got another example you can look at in your book, but then let's go ahead and do the practice, and I'll be putting them up here while you do them. You might want to stop the tape or video and go from there. So if I'm plugging this into the distance formula, I would say, let me label my points. Negative 4, take away a negative 2, quantity squared, plus negative 4, take away 4, quantity squared. All right, so in here, I have a negative 2 getting squared, which is 4. Here I have negative 8 getting squared, so that's 64. And so this answer is radical 68. Now, is there a perfect square factor? Yes, there is. This is 4 times 17. So the square root of 4 is 2 square root of 17. So that is your answer to A, practice A. All right, so let me work on practice B. In practice B, we're just going to find the slope. So we're going to plug into M is y2 minus y1 over x2 minus x1. All right, so x sub 1, y sub 1, x sub 2, y sub 2. So slope, I shouldn't say equal here, I'm going to say m equals -3, take away a -7, -8, take away a -4. And remember to add the opposite, and I get 4 over -4, which is a slope of -1. Okay. And our last one, C, we have 4, 7, and we have -14, -12. So the slope would be the change in y, -12, take away 7, over change in x. And so adding the opposite, I would get a -19 over -18, which is 19/18. So sometimes you will get a really weird slope, because that's a weird number. All right, so go to Renweb. You see your assignment. Best wishes, and we'll talk to you soon.